Hey friends, welcome to follow up. In this video, let's have a look at problem 141, linked list cycle. This is an easy problem, and actually we are going to present a method called fast slow pointers. So here we are given a list, a linked list, and we want to determine if the linked list has a cycle or not, right? So if you look at the examples, so in the example 1 and example 2, then the returns are true respectively. And in example 3, it's false. And so what's the difference of a linked list with cycle and without cycle, right? So if a linked list without a cycle, then if you move a pointer and continue, then the pointer will stop at null, right? For example, let's consider this one, say 1 point to 2, point to 3, and point to 100, then point to null, right? So this is the end. So if you have pointer here, so then you keep moving the pointer here, here, and here, and here. Then you're going to end at null, right? So this is a linked list without cycle. But now if I return back and then point to say 2, right? Point to the 2 here. So from 100. Then if you do the pointer, then next time once you arrive at 100, you are going to look at 2, and then the next will be 3, and then 100. Then you are going to enter a cycle, and if you keep moving the pointer, so this procedure will continue, never ending. So that's the difference of linked list with cycle and without cycle. So you can also look at the look at this point using example 1 and example 2 here. So once you notice that the difference lies in if we moving pointers, so there's either ending or either non-ending, so corresponding to without cycle and with cycle. So we can use two pointers. One is slow and one is fast. So as long as they continue moving, so the two will meet, right? So we can use example 1 as an demonstration. So assume we have two pointers. So originally both pointing at, say, at the node 3, right? So list node 3. So I'm going to use 3 to represent the node, right? Then each time, so the slower one, P1, we're going to move one step. And the fast one, P2, we're going to move 2 steps. And then what's the situation? So in step 1, so then the slower one, P1, will be 2, right? Well, the fast one will be 0, right? So this is step 1. So now let's continue. So move P1 from 2 to 0, then P2 from 0 to -4, then to 2, right? So it's going to be 2. And then we do it again. So P1 will move to -4. So P1 equals -4. Then because P2 moves twice, so from 2 to 0 and 0 to -4. So we get P2 equals -4. So they meet, right? Which means that there's a cycle. So that's what we are going to do in the coding. So once you realize this procedure, for doing the coding, actually it's rather straightforward. So what we are going to do is like this. We have a slow pointer, we have a fast pointer. So originally both pointing to the head. And then we are going to do this procedure. So we are going to do a while loop. So the condition will be this, because we need to move fast twice. So we're going to use fast and fast next. If fast is not null, then we can think of fast next, right? So if fast next is not null, we can continue. So because the condition will be this, slow, so we want to point to slow next, and fast, we want to point to fast next. because the condition is that first next is not null. Then we can think of, or we can talk about next, right? So this is our major step, like here, right? So then we're going to do an comparison. If slow and fast are the same, same means the same list node. So we are going to return true. Otherwise, after we exit this while loop, if nothing has returned, it means that we have arrived at an end or null. So we are going to return false. So this actually forms a solution format to this problem. So actually this fast slow pointer, in the context of this problem, it has bears a name for algorithm. So it's very simple. It's called Floyd algorithm. Let's see. Algorithm for cycle. So with that said, let's first do a test. So let's run this code. Yeah, it is true. Now let's look at the generic case. Yeah, it passes all the cases. So lastly, I want to mention that we have a list on linked list. If you are interested in problems related to linked list, actually you can check out that playlist. Hopefully it will provide you some useful information. So with that said, I guess that's it for the current video.